Rolling motion. I'm sure you're familiar with the idea of something rolling, but in physics, when we talk about rolling motion, we're often talking about an object rolling without slipping where the object meets the surface. For example, a normally moving car has tires that undergo rolling motion, where the tires don't slip against the ground. On the other hand, a race car that's at the starting line might have its tires slip some against the ground as the car starts moving. That is not considered rolling motion. When the tires of a car are rolling without slipping, there's a direct relationship between the tangential speed of the edge of the rotating tire and the linear speed of the car. The linear speed of the car is equal to the distance that it travels over the time it takes to travel that distance. The tangential speed of a wheel is equal to the arc length that it rotates through over time. If the motion of the wheel is rolling motion with no slipping, then when it rotates through the arc length s, the linear distance it has traveled is also equal to s. The linear distance the car has traveled is equal to the linear distance the wheel has traveled. This means that the linear speed of the car is equal to the tangential speed of the tire. It follows then that the linear acceleration of the car is equal to the tangential acceleration of the tire. The tangential speed of the tire is equal to the radius of the tire times the angular speed of the tire, if angular speed is in radians per second. And tangential acceleration of the tire is equal to the radius of the tire times the angular acceleration of the tire, if angular acceleration is in radians per second squared. So you can also relate the linear speed and acceleration of the car to the angular speed and acceleration of the tires.